we worked on solving radical equations, and I show you this example. The square root of p plus 5 equals 9. I don't know if you remember, but now I need your answer for this. We apply this step by step, the procedure, and then you have, first thing you have to do is to isolate the radical. So you're going to isolate the radical in one side of the equation and move everything else to the other side. That's what you have done here. The positive 5 moves to the other side as a negative, so it becomes 9 minus 5. Then the next step, you just simplify. 9 minus 5 equals 4, right? So you have square root of p equals 4. And the one step before the end, you just apply the square on both sides. You're going to apply the same index as the radical on both sides, as the power of both sides of the equation. And what is the number that's missing here? That's the question. Tell me, send me a message. There's a number missing. Is the answer to the question? What is the number? Check it out. If you remember yesterday, you will have in your mind the right number. If you don't remember, just check this step before, and maybe you can figure it out by looking at the step, one step before the end. 4 squared is 4 times 4, and the answer is 16. 16 is the right answer. That's right. Thank you, Kiara. Thank you, Jonathan. Thank you. Right. And I'm happy because if you didn't remember, maybe you look at this screen and you keep it in your mind. Try to remember this step by step, because we will apply again today. Yesterday we are working on equations with just one radical. Today we will apply, going to work with equations with two radicals. It's kind of the same step by step. Just one little thing that you have to check, one thing more than yesterday, okay? So keep this in mind. Thank you again. That's the right answer, 16. And moving on. The procedure we seen yesterday is this. Today we're gonna just add one little thing, okay? Step number 1, isolate the radical. If you have two radicals, then you have to choose one. If you cannot isolate both, one radical in one side of the equation, another radical in the other side of the equation, then you choose just one to isolate, okay? Step number 2, raise each side to the power equal to the index. Step number 3, solve the resulting equation. And now you're going to add this step here. If the equation still has a radical, you repeat. You go back to step 1 and repeat step 1 and 2. Okay? And finally, on step number 4, check if your solution is good by plugging into the original, the first equation that you started. Okay? Now let's move. Now let's, when we read this kind of thing and we try to make sense by just reading and rereading, is really hard. But usually when we apply to an example, it's much better to understand. That's what we're going to do, and apply the procedure to that example. Solve the equation, and we have the cube root of 2x. Oops. Cube root of 2x minus 4 equals to cube root of 1 minus 8x. Okay, that's the example. We have two radicals on this equation, and the first step is to isolate, and they are already isolated, so you can skip step number 1, move to step number 2. Now you're going to apply to both sides of the equation the power equivalent to the index, so the power of 3 to both sides. Okay? Now you can simplify this cube root of this power of 3, this cube root of this power of 3. Simplify, because you're going to have now 2x minus 4, this simplified, equals to 1 minus 8x. That's cool, because we don't have any radicals now. We have just a very simple equation, apply addition property, multiplication property, and maybe you're going to be able to solve it, right? Applying addition property, we're going to move this, all the numbers to one side, all the variables to the other side. So move this to one side of the equation, is negative, it will become a positive, and move this to the other side, it is negative, will also become a positive. Then we're going to have 2x plus 8x equals what? 1 plus 4. Cool? 2x plus 8x, 10x, 1 plus 4, 5. That means x equals 5 over 10. And we can simplify because we can divide the numerator and denominator by 5. X equals 1 over 2. That is the right answer. Well, it's supposed maybe is the right answer. Don't forget the last step, okay? The last step of the procedure, you have to plug in 1 over 2, the answer that you just found, into the original equation. So plug in here 1 over 2, plug in here 1 over 2, and then check if they produce a true statement. Cube root of 2 times 1 over 2 is 1, 1 minus 4, negative 3, cube root of negative 3 equals cube root 1 minus 8 times 1 over 2 is 4, 1 minus 4 is negative 3, cube root of negative 3 equals cube root of negative 3. Yes, this is correct. This is a good answer, a right answer, a right solution for the equation. Have a look at the solution and tell me if you can understand. If there's anything still confusing, let me know. I think it's easy, but it's my view. Maybe I'm wrong, because I've seen this several times and now I can understand. But for you, some of you are looking at this for the first time. So tell me if there's anything confusing, anything that you don't understand. If you don't like this solution, you can check the one on next slide from the book. See, it has more details. Maybe you can understand better. Okay, but it's very important that you understand, since we will work exactly using this procedure on the quiz today, and you're going to have several questions on the test after tomorrow, just like that. Give me feedback if you want. Tell me if you understand, if you have any questions, because if not, we can move on and practice and try to solve the questions of our quiz. Okay? I don't see any feedback, any questions, and if you don't have questions, let's move on. But first, you need to answer the bell work. What is the answer for this bell work? How many times is the large fishbowl greater in volume compared to the small one? Can you find out how I calculate it? I'm going to prove that we don't need to use the formula of the volume. And I'm going to say at least one student got very close to the right answer. We will need the radius of the large one. Let's say the radius is capital R equals, and the radius is R times cube root of 3, and the radius of the small one. Small is just lowercase r. So those are the radius. Okay. And we can calculate the volume. Yes, we can calculate the volume. The volume of the large one is 4 over 3 pi capital R cubed. Okay. But I'm going to prove that we don't need this formula. The volume of the small one is 4/3 pi, pi lowercase r cubed. Okay? So this is the volume of the small one. Now we will compare. What we need to find the answer is to compare and divide the volume of the large one by the volume of the small one, right? That's what we're going to do. Volume of the large over volume of the small. Volume of the large one is 4/3 pi capital R cubed. Volume of the small one is 4/3 pi lowercase r cubed. And pay attention, we can simplify everything. We're going to have at the end capital R over lowercase r cubed. See? We simplify the formula, we don't need the formula. And the answer, since capital R is r cube root of 3 over r cubed, this r is also simplified. The answer is going to be cube root of 3 cubed. Simplify this with this. The answer is 3. 3 is the right answer. 3 is going to be the right answer for this bell work. And I'm going to tell you, Keon Harding, very close to the right answer. Yes, very close to the right answer. And most of you answered 20, but 20 is not too close. It's kind of it's kind of a good answer, but not too close. Keon, you got closer to the right answer. Just remember, okay? On the test, I will ask something similar, and you're gonna reply. On the test, today is 3. On the test, you're gonna check this number. You're gonna apply submit to the power of 3. If we're talking about volume, you use the cube, and the answer is gonna be this number cubed, like here. Cube root of 3 cubed is 3. On the test, the same thing, only the number is going to be different, okay? But the way of finding the right answer is going to be the same. Okay? No questions? Now I don't know if I do get it. I will need more practice. Yes, you can practice, you will, no problem. Just remember for the test that the answer is going to be this thing here, this thing, cubed. Maybe I'm gonna use a different number, not 3. Instead of 3, I can use 4, I can use 5, but it's gonna be this number here, cubed. That's going to be the answer for the test. All right. Now let's work on our quiz. Solve the radical equations. If more than one solution, separate by comma. And the only questions that might have more than one solution are the last ones. J, K, and L. Okay? All the other ones just have one solution. For letter A, how do we solve it? We're going to follow the procedure, the step by step. On letter A, we have 4th root of h plus 4 equals to 4th root of 2h minus 5, right? We will, the radicals are already isolated, so we can skip step number 1. Now we're going to submit both sides by the power of 4, the same index, okay? Because now we can simplify. The 4th root, we can simplify to the power of 4. And we're going to have h plus 4 equals 2h minus 5. Nice? Apply addition property of equality. You can move this -5 to the other side. Remember, this is becoming a positive, and you can move this h to the other side, will become a negative, right? So we have 2h minus h equals what? 4 plus 5. That means h equals 4 plus 5, 9. This is the right answer. H equals 9. Now give me 1 minute, I will check attendance, and after that we can work together on more questions. For letter G, the first thing, isolate the radicals. So the radicals are here together in one side of the equation. Move this one that's negative to the other side. Okay? So you will have, the square root of 2h plus 5. When you move this to the other side, then you're going to have the square root of 3h. Now apply the square, the same index to both sides, the power of the same index to both sides, because you can simplify this square with the square root, and then you're going to have 2h plus 5 equals 3h. Nice! Nice, because if you move this 2h to the other side, it becomes a negative, right? Because it's a positive. You have 3h minus 2h equals 5. H equals 3 minus 2. H equals 5. Let me check. This is letter G. Now letter H. Well, same thing, because the radicals are all in one side. You have to move and isolate the radical. And now we have square root of k plus 16 equals the square root of 3k. So power of 2 on both sides. Power of 2, this square both sides, because you can simplify. And then you're going to have k plus 16 equals 3k. Move this little k here to together with the other variable, and then you're going to have 3k minus k, 2k equals 16. K equals, let me just squeeze a little bit. 2k equals 16. K equals 8. K equals 8. Thank you, Chiara. We have G and H. Letter K, we might have two answers. Let's check it out. Well, they are already isolated, right? They are, the radicals are already one on each side of the equation. So we're going to apply the square on both sides, like this. Then we have the square root of 18 minus p. Oops. That means we can simplify the square root of the square. We can simplify the square root of the square. And then we're going to have 18 minus p cubed equals p cubed plus 2. Nice? Move this negative p to one side. Becomes a positive p. Move this positive 2 to the other side. Becomes a negative. And then you will have p, just let me see, 18 minus 2 equals p cubed plus p cubed. Nice? 2p cubed equals, we can switch, no problem. 2p cubed equals 16. P cubed equals, divide both by 2, and then have p cubed equals 8. Now you have to apply cube root to both sides. Cube root to both sides of the equation, okay? And now we have p equals 2. This is going to be the only answer. If we try negative 2, negative 2 is the cubed, negative 2 cubed is negative 8. So it's not an answer. The only answer is going to be p equals 2. Thank you, Terrell. Let me show real quick letter L, because letter L, we're going to have two answers, okay? That's slightly different, because now we have square root of z squared plus 1 minus the square root of 2z squared minus 3. So move this, isolate the radical, move this to the other side, and then we're going to have square root of z squared plus 1 equals the square root of 2z squared minus 3. Right? Now apply the square on both sides. The square on both sides, because we can get rid of the square roots by simplifying, and the result is going to be z squared plus 1 equals 2z squared minus 3. Move the z squared to the one of the sides. Put together all the variables, right? And move this negative 3 to the other side, put together all the numbers. It will be a positive. 1 plus 3 equals 2z squared plus z squared. And you can switch the sides. 3z squared equals 1 plus 3 is 4. Apply the square root on both sides, but remember, maybe we can have this as a negative as well. Let's check it out. This square root can be positive or negative. No, I did something wrong here. This is negative, and this is just z squared. Yeah, now it's right. Now looks better. We can simplify this square root of the z squared. So we have z, and the answer can be negative 2 or 2, because if we square negative 2 is 4, and if we square 2, the same thing, 2 times 2, 4. Those are the two possible answers for letter L.